You guys can hear me, right? Okay, I can't hear you. So let's see. Let me close out Discord really quick. How about now?
I can hear you.
Wonderful, sweet, awesome. Do you have questions?
Mr. Strickland, did you hear my question for 11?
No, I didn't. So you
Okay,
want 11? I got you.
yeah, we just got through, when we did the exclusion stuff, we got hard bracket -7 to -3/4 soft bracket.
11, 12. So let's take a look. First of all, yeah, okay. So let me pull up my worksheet. So let's take a look at 11. So square root d plus 3 plus square root d plus 7 greater than 4. So, from the equation, I suspect you got d greater than -3/4, which is correct. And then, from this guy, we get d greater than -3, greater than or equal to. And then from this guy, we get d greater than or equal to -7. So if you throw all three of these on a number line, you have -7, -3, and -3/4, all. So this one's not inclusive, pointing to the right. These two are inclusive, pointing to the right. And like we said, these are always and statements. So I need to keep moving left to right until vertical lines pass through all of these statements, and it starts here at 3/4. So this is the most restricting of the three. So that's why that's our answer. Does that answer
So
your question?
at the -3/4, do you have to like FOIL it? I mean,
So are you asking me how I got this answer?
yeah,
I can show you here in a second, but Gary, did that answer your question? Is Gary
When you
alive?
square negative numbers, do you have to flip your sign when it's a inequality?
Oh, so yes. So tell me what you did, and let's.
Well, okay, we did it a little bit of a different way. It was kind of long, but we eventually got down to d minus 20 is greater than 8 root d plus 7.
So did
I
you
think
get
we
positive 3/4?
No, we still got -3/4. We just got -3/4 is greater than d.
Did you square the left side without changing it?
I think so, without flipping the sign.
Well, so at the start of the problem, did you just square both sides without changing anything?
Eventually, I think maybe we did. We squared a negative number. Is that when you flip your sign?
Yeah.
Okay, then that's the problem.
Yep.
Thank you.
Okay, so Dylan, I'll show you how we get that. So I'm just gonna move one of these to the right. So I get oh goodness, square root d plus 3 greater than 4 minus square root d plus 7. Square both sides here. I get d plus 3 greater than 16 minus 8 root d plus 7 minus d minus 7. Is that correct? Seems right. So, wait, maybe not. This... Four minus root. Where did 8 come from? From foiling it. Yeah, because so you square this guy and foil this. So you get -4 roots and -4 roots. So here's our -8 roots. Oh, this would be plus d plus 7. Cool. That's better because then these cancel out, which is nice to see. So I get, so on the right side is 23, so I'll subtract it over. -20 greater than -8 root d plus 7. This is probably what happened, Gary. Then you have to divide by -8, so you get 28ths, flip the sign, less than root d plus 7. 28ths is divide by 4, 5 halves, less than root d plus 7. I'm going to go ahead and square both sides. So 25 fourths, subtract 7 minus 28 fourths, less than d. So d is greater than -3/4. Is this good, Dylan?
Yeah, man.
So were you saying whenever you square a negative number, you have to flip a sign?
You have to flip an inequality if you're squaring something that's negative, yeah.
Okay.
For sure. Okay, also number 12. So number 12, root 4 minus x equals x plus 2. Let's see. Whoops. Oh, it is an equation. Cool. Okay, so square both sides. I get 4 minus x equals x squared plus 4x plus 4. So, subtract 4. I get x squared plus 5x equals 0. 0 equals x quantity, x plus 5. So x is either 0 or -5. And we find out that -5 does not work. Is this good, Grim?
Oh yeah, on the answer key, I had 3 for the answer.
Yeah. I wrote down a different equation than I meant to. Alright. Cool. Let's get into it. Alright, before we talk about what we're actually doing, I just want to go over the distance formula. So we've seen this before, I know for a fact. Maybe you don't remember it, and I want to show you also where it comes from. So consider that we may have, well, it's not may have, we do have 2 points floating in space, and I'm just going to give them arbitrary x and y values. We're going to create the distance formula from scratch right here, right now, because we have the power. Okay, so a and b, I'll give b x2 comma y2. These are just subscripts, right? This is the second x value. So the question is, how far are these guys apart?
Who knows?
Well, we're about to know here in a moment. And so the way we're going to do this is we can create a triangle. And so I'm going to make a leg along the x coordinates just completely flat. I'm going to make a leg along the y coordinates just completely straight up and down. So we can then use Pythagorean theorem on these 3 sides, right? So in a right triangle, as we know, we have a squared plus b squared equals c squared. So c squared equals a squared plus b squared. But in this instance, hypotenuse c is the distance we're looking for, right? So we have d squared equals, we just have to find some kind of expression for these sides. Well, this bottom leg is just running from x1 comma y1 to, well, the x coordinate is changing, but the y coordinate is not changing. The coordinate over here will be x2. It's moved over to be horizontally in line with this guy, but it's still y1 units tall. So if I want to find the actual length of this leg, it's just the horizontal variance from x1 to x2. So the length is x2 minus x1. And similarly, the length of this height leg is y2 minus y1. It's just the variance in y coordinates. So I replace A with x2 minus x1 and B with y2 minus y1. And where'd that, okay, plus, and there's our distance formula. I'll just go ahead and isolate for D by taking square root of both sides. So D equals square root x2 minus x1 quantity squared plus y2 minus y1 quantity squared. So the distance between two coordinate pairs is the difference in their x values squared plus the difference in their y values squared, and then take the square root of that. It's literally just Pythagorean theorem. So if you ever forget, you can literally make it from scratch, which is nice. Or you're certainly welcome to rote memorize the formula, which I don't recommend, but we're all different learners, so that's your prerogative for sure. Any questions with the distance formula?
Nope.
All right. So let's talk about circles. First of all, what is a circle? Well, a circle is the set of all points. We can write in gray, I guess. Set of all points equidistant. This means equal distance, equidistant from a central point. Right, this is the center of the circle. I'm going to do my best to draw a circle here, and it's not going to be very pretty. So we say all of these points are, geez, I wasn't kidding. I'll take that. All of these points are r units away from the center.
Are they though?
Well, I said they are. They are, right?
I'm sure.
Yeah, I know. So, this distance is r, right? From all these points to the center. And sometimes this will be O or P or C. I'll just call it C. It's no big deal. Okay, we know what a circle is, right? So, imagine if we actually draw a bigger circle here. That's a little more convincing. Not really, though, but let's take a look. So, say our origin is just something general, x1, comma, y1. Now, knowing the distance formula, we can derive the equation from a circle. So, where this is the center, all these points on the outside are just our x and y pairs. Remember, the graph of an equation is the set of all the points that satisfy it. So in other words, we are asserting that x1 comma y1 is r units from x comma y. Well, let's just plug that into the distance formula, right? So I'll bring, actually, let's see, I'll bring the distance formula down here. Does it not work that way? I feel like it did once upon a time. Okay. So I'll just rewrite it. That's no big deal. So distance is the square root of the difference in the x coordinates squared plus the difference in the y coordinates squared. So what's the distance we're talking about here is r. So r equals the square root of the difference in the x coordinate square. Well, the first x coordinate we'll just call x. That's any arbitrary point on the outside of the circle. So x minus the other x coordinate, which is x1. In fact, I'm going to change this from x1 comma y1 to h comma k. We've seen these letters before with vertex form. So this will be x minus h x minus h quantity squared plus, oops, y minus k quantity squared. So we get y minus k. And this is the equation for a circle centered at h comma k. So the radius is r. And the center is just h comma k. Notice these arbitrary h and k are positive, but it's x minus and y minus. It's just like point slope formula and vertex form. So this is the general equation of a circle. All circles are of this form. Does somebody have a question?
No, it's just I had this smart idea of putting my thing on my command button.
Nice. Okay, so I will leave this right here, and I would like you to do two things. So we have two problems here. Find the center and radius of this circle. Let's say 20 equals square root x minus 3 squared plus y plus 4 squared. And then also write the equation of a circle. And the circle will be centered at -1, 2 and radius 7. So go ahead and attempt these two problems. I actually forgot to mention something. This circle equation that I wrote here is not what is most popular. Like, that's correct, but usually instead we will see it as r squared. I'm just squaring both sides here. R squared equals the stuff under the square root. So I'm going to change my other one to mirror that. So after I finally erase this guy. So this would be 20 squared, or 400. And really the reason it's usually expressed this way is to avoid all the business with principal roots and whatnot. All that tomfoolery. Please let me know when you finish. Thank you.
Finish. Let's just.
What's that? Anybody still working? Let's take a look. So our radius here is square root 400. We get 20. And our center is going to be positive 3 comma negative 4. And so for number 2 here, we would have r squared, so 49 equals x plus 1 squared plus y minus 2 squared. Any questions about these two? So I want to make a quick comment. Imagine if we have something like 44 equals x plus 3 squared plus y squared. And so the y coordinate would be 0. But what I'm really talking about is the radius here. So the radius squared is 44. So if I want to know the radius, it's the square root of 44, which we know is 2 root 11. So I just wanted to mention that we will see some stuff like that on the homework, just simplifying square roots.
Why is
So
it
do-
not negative 3 for on the
Up here,
yeah?
you switch the sign. So negative 3 means positive 3, and positive 4 means negative 4. Just always switch that sign. Does that make sense?
Yep.
Cool. Alright,
I have a
so
question.
go ahead.
Whenever like you do it, do you not need like the square root on the outside? Like on the second one, how you have 49 equals
Yeah.
like
Yeah, so earlier I mentioned this, but maybe you didn't hear me, which is fine. No big deal. I had it written this way, which is not incorrect, but usually that's not how we express it. Instead, we would square both sides, so this square root goes away, and this becomes r squared.
okay.
And that's to avoid all the business with principal roots and whatnot. Is that good?
Yes, sir. Thank you.
Sounds good. Alright, let's continue. Let's graph one just to see what that's like. It's not too bad. So say we have 16 equals x plus 2 squared plus y minus 3 squared. So when you graph these, what I like to do, and on your homework you will have grids, thankfully. So when you graph these, just determine the center. So the center is what? Negative 2 comma positive 3. So go ahead and graph the center. So I go to negative 2, positive 3. And then it will vary radius units up, down, left, and right. So radius here is actually 4. So I'll go 4 units up from the center, 4 units right from the center, so 1, 2, 3, 4. 4 units left from the center, and 4 units down from the center, 1, 2, 3, 4. And then just connect those outer points. So because the scale of my graph is kind of rectangular, it's going to look more like an ellipse. But that's no big deal. We're just going to accept that I can never draw a circle. Here's my circle. It's beautiful. Don't body shame the circle. So graphing these is pretty easy. So these are all 4 units away from each other. Believe it or not, it doesn't look like it, but so you'll have a couple graphing questions there, and also you could easily, and we would see this maybe every now and then, but this isn't on the worksheet, but you could certainly be given a circle just on a graph, and it has the center at a point, and it has the radius denoted, and you would be asked to write the equation, but there's not too big of a deal, not too bad. Right, so there's one thing. So if you take a look, this is nice and neat. This is the standard form of a circle. The reason it's the standard form, the reason it's used so often, is because it's readily apparent what the radius and the center are. But the circle equation can look like something else. In fact, I'll show you a circle. X squared plus y squared minus 8x plus 12y minus 12. This is a circle, believe it or not, and so the goal we would want is to actually be able to put it in a form where we can find the center and radius. Because that's what we really need to know about a circle. Well, this form is not helpful at all. Eventually we want it in standard form, which is x minus h squared plus y minus k squared equals r squared, right? Earlier the r squared was on the left, but it doesn't matter for an equation, of course. Okay, so how do we turn all of this junk into a sum of squares on x and y? How do we create something that looks like this? Well,
Please don't tell me that we have to FOIL.
no, we don't have to FOIL. So the way we create something like this, we've already been doing it, is just to complete the square. So we want to complete the square on the x's. So let me just go ahead and rearrange this. So I have x squared. I'm going to put the x's together because they belong together. They're good friends. I'm going to put the y's together. Also excellent friends. And then I'm just going to, I guess I'll go ahead and move that over. So negative 12 became positive 12 on the other side. So I put the x's and the y's together. So this x squared minus 8x will become this. I just need to complete this square. And this y squared plus 12y will become this. I just need to complete the square. So if you forget how to complete the square, don't worry. Just take this middle term, as you may or may not remember, divide by 2. So that would be negative 4, and then square it, and then you add it in. So we get plus 16. Well, if we're going to add it on the left side, we also need to add it on the right side. And then also for the y's, I'm going to take y squared plus 12y, take 12, divide by 2, 6, and square it, add 36. And same story. We need to balance both sides. So if I'm going to factor the left side, this will be x, keep the sign, minus divide 8 by 2, 4 squared. That's completing the square, right? This negative 4 squared, you get 16, and times 2 is negative 8. That's how completing the square works, right? And similarly, we get plus y, keep the sign, plus 6, quantity squared equals, what is this? Oh, I don't need those equal signs, that's fine. equals, what is that? 28 plus 36, it's 64. Okay, so there is what we needed, right? And so in order to do that, all you have to do is complete the square. And so let's go ahead and find the center and radius. Well, the center would be 4 comma negative 6. And the radius will be 8. Square root 64. Any questions about this? Okay, I'll give you one to try. And so I would like you to do this same process with running out of colors here. X squared plus y squared plus 4x minus 10y minus 7 equals 0. So please do this problem here. Find the center and radius.
Yeah, I did it.
Anybody else done?
It sounds like you're cleaning dishes in the background.
Sorry, must be my water bottle with the ice.
Or like baking pots and pans or something.
Okay, so what is? I didn't even write the answer. Looks like I'll have to do it from scratch. So you should get x squared plus 4x plus 4 plus y squared minus 10y plus 25 equals 36. X plus 2 squared plus y minus 5 squared equals 36. So center is negative 2 comma 5 and radius is 6. Is that what we got, y'all? I'll assume that's a yes.
Yes,
Alright.
yes, I did. It's just like I didn't write down the C and the R. I had it in the equation form.
What's your question, Graham? And Arshia, you always flip these signs. So y minus 5 becomes positive 5 for the y coordinate. So these are the numbers I created, Graham, in order to complete the square. And so this became 7 plus 4 plus 25. Okay, so we're good. Cool. Okay. 7, 6, and negative 1, negative 8. So the last variety of problem we're going to talk about, you may be given just the diameter endpoints. So before we discuss the strategy here, let's go ahead and graph it. A picture always helps. If you can draw a picture, you absolutely should. So 7, 6, I'm just going to eyeball it. We have 1 point over here, and negative 1, negative 8, we have another point over here. This is the diameter of our circle. I guess I'll do it in yellow. So, there's basically going to be 2 semicircles. Oh my goodness. Let's see. That's almost decent. It's almost passable. So I need to find the equation of this circle. Alright, we'll practice drawing circles later. So let me label these points. We know what they are. And 7, 6. Well, if I want the equation of the circle, I'm going to need 2 things, right? We need the center and also the radius. So we need to know where this is, and we need to know what this distance is between these guys. Okay, so what do we know about the relationship between the radius and the diameter? Well, the radius is just half of the diameter. But how do I find the diameter? Well, the diameter is just the distance between these 2 points. So let me go ahead and do that. Doesn't matter which one I call point 1. I'll just call this point 1. So x2 minus x1, I get negative 1 minus 7. Whoops. Squared plus y2 minus 1 minus y1, negative 8 minus 6 squared. So that would give me the diameter, and then I need to divide by 2 to get the radius. So this would be square root negative 1 minus 7, that's 8 squared is 64, plus negative 8 minus 6 squared, that's 196. So this is square root 260. I know for a fact that I want to simplify this if I can. I know for a fact that 4 comes out of 260 and it's 4 times 65. So that's the same thing as square root 4 times 65. Square root 4 is 2, so I get 2 root 65 over 2. So that's just root 65. That's our radius. Any questions about how we found the radius? You can find the midpoint first and then just do the distance formula between these 2 points. But the reason that I would not recommend that is sometimes this midpoint might be decimals or fractions or something like that, and you really don't want to put that inside here. Your life's gonna be easier if you do the distance first. And so if we want to find the center, I actually already I'll answer your question here in a second, Graham. If we want to find the center, I already said it inadvertently. We'd have to do the midpoint formula on these 2 points. So the reason this is divided by 2 is ultimately we're looking for the radius. So we want the radius, which is diameter divided by 2. The top is the distance formula for the diameter, and that will give us the diameter, and then we divide by 2 to get the radius. Does that answer your question? Wonderful. So, and if you don't remember midpoint formula, we won't go through all the hassle of deriving it because it makes a little more sense. The midpoint formula, you just take the x coordinates and you average them, then you take the y coordinates and you average them. Very easy. So we get x1 plus x2, I get 7 plus negative 1, 7 minus 1 over 2, and then 6 plus negative 8 divided by 2. So this becomes 6 halves, which is 3, and negative 2 halves, which is negative 1. There's my center. And radius, so I just need the equation now. So I'm actually kind of running out of room, but that should be fine. I get r squared, so 65, equals x minus 3 squared plus y plus 1 squared. Here is our equation. So that's about as hard as these would get, for the circles at least. We have more shapes coming up, so be excited. I just want to mention that, interestingly, any 3 points define a unique circle. So we could find the equation of a circle given 3 points, and the way we would do that is by taking all 3 points and then just plugging them in to the circle equation. Where is it? Where'd it go? This guy. And then you can do a system of 3 equations to find the circle that goes through them. So that's interesting to think about. But we're not going to do that because that's actually quite involved algebraically. Besides that, we're donezo. These are circles, and your homework is on the portal. And I hope you guys have an incredible Monday.
Thank you.
Peace, y'all.
Thank you.